glad you could all find me down here. We're a bit hidden away. I'm Andrew Morgan. I work for MongoDB as a developer advocate, and my focus is on the Realm mobile database. So that's the database that's actually embedded within your apps that's running in your Android or iOS app or other platforms. First thing I was going to say is I was quite happy. I'm really happy we're in this building. When I arrived yesterday, I realized that the first and last time I was in this building was at a graduate recruitment fair where I got my first software developer job. And when I arrived, I got in there, looked at all the stalls there, and I was drawn straight to one that was called STC Submarine Systems. And I thought, wow, that's where I'm going to work at. But it turned out by submarine systems, they actually meant laying telecoms cables under the ocean. And what's more, they'd actually just been taken over by a Canadian company called Northern Telecom, and they'd sold that division to Alcatel, the French company. And so what I actually ended up working in is mobile development. So that's cool. But this is literally what was state-of-the-art mobile phones at the time. So it's before 2G had been, so the GSM standards, which were the standards for 2G, they'd been defined, but they weren't complete. And so we were working on developing against the standards that haven't even been finished yet. And this is one of the phones that we actually had in our lab to do the testing. I forgot to bring it in with me because this one actually made its way to my cupboard when the department shut down somehow. But it's about the size of a shoebox, weighs half a ton, but it did have a removable battery, which is one over on an iPhone, which, to be honest, is just as well because the battery lasted about 20 minutes on a full charge. So that makes you think that I'm eminently qualified to talk about mobile development. Well, not really, because I was actually coding one of these. So in the GSM mobile network, there's actually a huge distributed data distribution problem being solved there. So I worked on a real-time database that sits at the core of the network. So if you were a 3 UK subscriber, all of your data would be stored in this database. If you roamed from London to Oxford, then this database would send all of your data to an exchange in Oxford, so it's local to you. And we also get notified that you're in Oxford, so if someone calls you, we know to route you to Oxford. So this is the beast that we were programming, and each of these cards, they're 19 inches tall, and this is 96 megabytes of memory that was stored in there. And so basically, we were storing data of about 10 million subscribers in less than a gigabyte of memory. But it was very fast and very reliable. But anyway, back to what we're actually meant to be talking about today. I've eaten some of my time, so we're running a bit behind. But this is the app we're going to build. It's a chat app, so if you like, a very light version of WhatsApp or Slack. And you have a number of chat rooms. You can pick what those rooms are. People go into those rooms, and they can exchange messages with each other. Sort of very, very simple, but it is actually transmitting data between these apps. So that's what makes it a bit more interesting than the standard Hello World app. We're going to be using SwiftUI, and really that's the default. When you're developing an iOS app now, SwiftUI is the default. You can still go back to UIKit if you want to, but people are being pushed towards SwiftUI. And that's the framework that Apple now, when they're adding new features to their own apps, they're developing them in SwiftUI. So how many people have used web frameworks such as React or Vue? Okay, most people. A lot of the concepts with SwiftUI, they're going to seem very familiar to you. Sort of different terminology, but the same idea. They're both data-driven or state-driven. So in SwiftUI, everything you see on your screen is a view. So the app, the window, everything there is a view. Views can be composed of multiple smaller views. In fact, they almost always are. And you have some special views, such as a vertical stack or a V-stack. So that means that you have views piled on top of each other. You also have horizontal stacks or H-stacks, where things are placed side by side. And then you have Z-stacks, where things can be placed in front of each other. So you might use that, for example, if you wanted a progress spinning wheel, sort of, you might use a Z-stack to put that in front of the main app. You can have conditional views, so you can have code in your app that says, if this condition is met, then display this view, otherwise display that view. You can jump from one link to another. So there's a view called navigation link, which lets you jump between views. And it's a bit like, clicking on a HTTP link in a HTML page. And whether it's child views within a view or jumping from one view to another, you can pass parameters. So, like I say, this should all seem very familiar to people who have used things like React. You can use a binding. So by default, the parameters are passed by value. But if you want, you can use the binding annotation to make it pass by reference. So if the child view, for example, updates the parameter you passed in, it'll be reflected in the parent as well. And we're going to use that in the app. What you see in the app is driven by state. And for some of the state we're going to use in this app, it's very tightly coupled with the Realm database, which is embedded within the app. So the chat messages themselves, they're all going to be persisted in Realm. And the nice thing is that you're going to see that if something changes in the Realm database, the UI gets updated or the view gets updated, and you won't see any code that's writing observers or doing event handling. It's just all handled by SwiftUI and Realm. So the data changes in Realm, your view gets updated. And we'll see how that works. So final comment about views. In a typical app, you've got a lot of them. Here, each of the braces is showing a view, and there's actually a lot more of these. So for example, these messages, they're sort of in a VStack. Then we've got a special view called a spacer to push those to the top and the chat input box to the bottom. In reality, we have a view here that takes the message. When we add a bit of space around it, that's actually another view. When we color the background yellow, that actually creates another view. When we put the rounded corners on, that's another view. So like on this screen, I haven't counted, but there's maybe hundreds of views actually on this screen. And with SwiftUI, they're designed to be extremely lightweight, so you don't have to worry about creating lots of views. So MongoDB Realm. So this is the data side of the app. So most people know MongoDB as a database company, and we have a cloud-based database called MongoDB Atlas. But we're going to be focusing mostly today on Realm, which is like I say, the mobile database, and we acquired the company behind that a couple of years. And so that's what we're mostly going to be focusing on today. But we do have a cloud side to Realm as well, which we're going to be using something called MongoDB Realm Sync here. So how the data works in this application is when you write a message in one instance of the app, it gets written to the local Realm database. Then that is going to interact with the MongoDB Realm Sync service, and it's going to copy that data to any other instances of the app that are running on other devices. And so this is why it's cool for something like a chat app, because you haven't got to worry about the messaging. You don't have to worry that this device may be offline when the message is sent. It doesn't matter, because when it comes back online, it'll automatically get caught up to date. I'm not going to demonstrate it here today, but you can actually continue sending messages when you're disconnected from the network, and they'll just be stored in the local Realm database. As soon as you have network connectivity, they'll automatically be pushed out. And then, as a bonus, this data also gets synchronized to MongoDB Atlas, which is the central cloud-based database. We're going to use partitioning. So we're going to partition our data, and I'm not going to talk too much about it, but there's two main reasons why you do partitioning. The first is capacity. If you've got 5 million subscribers, you probably don't want all of their data on everyone's phone. Otherwise, your app is going to use up all of their storage. So you partition the data so users only get the data they care about. The other is security. You probably don't want your bank details in an app on my phone, and so you can use partitioning for that. The partitioning is pretty simple. On the left-hand side, we've got our Atlas database. And in there, we've got a database of shapes. So we've got a collection for circles, stars, and triangles. But every one of those documents in each of those collections, they all have a common attribute, which is the color. So in this case, we're going to say we're going to use the color as our partitioning key. And so our mobile app, it says, OK, I want to synchronize all of the blue shapes. Or it could also open up another, not connection, but open up another synced realm and say, in this one, I want to access the red or access the green. For our app, we're going to use the name of the chat room as the partitioning key. So when you go into a room, it's going to open up a partition for that particular chat room. So that way you don't have to synchronize all of the chat room messages, only the messages that you're interested in at that time. OK, so with that, let us switch to actually building something. I shouldn't go back. Right, so the first thing we're going to do is we're very, very quickly going to create our backend app. And you just go to cloud.mongodb.com, and you create a project, which I'm going to skip that because you don't need to see me typing in my name and address. But it's very simple to register. Once you're in there, go for the shared tier, and then create a cluster. Make sure you've picked the free version, and it's free indefinitely, so you can run it up, and you're not limited on features. You can keep it running forever. You've just got limited capacity. So the only thing I'm going to change from the defaults is I'm going to have it based in Ireland, because that's our closest data center. So that's now spinning up the database cluster. While it's doing that, I'm going to create my Realm sync app. So I click on the Realm tab. Within here, there's a bunch of templates that speed you up. I'm going to go for build my own, because it's so simple. Give it any name you like. So let's call it DevOps chat. Check the regions right. So it's EU West, Ireland. And then we're going to create our Realm app. Get rid of that. And there's lots of things in here. First thing I'm going to point out is this is the application ID. So we're going to need to put this in our code so that our app actually connects to the right backend. So at any point in the app, you can just click on this little icon here, and you can copy that. So let's copy that. Then I'm going to jump on the left-hand side to the sync tab. There's two ways of defining your schema. The first way is if you've already got data stored in MongoDB, then you choose the left option, and it will generate a JSON schema based on your existing data. Or what we're going to do is we're going to have the schema be automatically generated based on the objects that we're storing in Realm in the mobile app. So we just select out the cluster we've just created. Remember, we were going to partition by room. It's a string, and let's call it DevOps as our database name. OK, so there's an error there, so it's just waiting for the database cluster to finish being spun up. Give it a second. OK. While it's doing it, so I've got a pre-built version of the app, and that app ID I've just copied. I'm going to paste that in there, and then I'll just put that to build. And the reason I'm doing this is I want to be able to put a message into Realm before we actually build our version of the app. So that way you can see that the message doesn't get lost. Yeah, it's still starting up. Oops, that's wrong. It usually spins up faster than that, but let's go back to our app. Otherwise, we can start coding our app and come back to it in a bit. Okay, there we go. Okay. And now we've finished with the back end. So I'm actually teaching you how to be a full-stack mobile developer here. So in here, we've got that existing project. I'm going to create a new one. So this is in Xcode, new project. So we're not going to need this one anymore. So let's get that out of the way, because we don't have a huge amount of real estate. Okay. Right, so once we get in here, I know this is a bit small and I can't increase the size of the UI, but the code I can zoom in. So we're going to create an iOS app. Make sure we stick to the default of SwiftUI for the interface, and we'll call this DevOps Chat. And we'll just create it. Okay. And I'm going to set up a couple of things right away. I'm going to be using a couple of features which are only available in iOS 15. So I'm just going to select the top level of the project, go to the target, and go to the build settings. I'm going to set it to iOS 15. Most of this works on previous versions, but I liked being a dev advocate. I like playing with the new stuff, and being a dev advocate, I don't have any customers running on old phones, so I can get away with it. So I realize not everyone has that luxury. And then I'm going to go to the project dependencies. The only dependency I need to add is the Realm SDK, and when you're adding a dependency with the Swift Dependency Manager, you just need the URL of the GitHub repo that you're taking the stuff from. So here it's GitHub Realm/Realm Coco. But again, sort of you can see that in the repo. Right, so let me go back to the app. So I know that I've tested this on a particular version, so I'm going to say 10.18.0. I didn't have to paste in the URL here because Xcode remembers any package that you've previously used. So, not sure how long this is going to take. Oh, it's there. That's cool. So just while that's setting up, I do need to go back to the one I built earlier. And I want to run this because I want to send a message from the existing version of the app. Okay, so I'm going to go to the Swift chat room and just say, I'm lonely. Okay. Now we really have finished with that. Okay, so now we can start looking at the code. Every SwiftUI app, when it's created, it's bootstrapped with this. The app main annotation tells us that this is the entry point. And you've got a bit of bootstrap code here, but the bit we care about is content view. So content view is our top-level view. You can change the name if you like. So we have that. So we're going to have a few views. So I'm going to create a group for our views. And I'll just move content view into there. Right, so in our chat app, the first thing we're going to do is we're going to connect to the Realm backend. So this is connecting to our cloud sync service. And the first thing that happens is we get a build error because both sort of the Realm guys, maybe a bit ego too high, decided that they'd use app as what a SwiftUI app or a Realm app is going to be. And the SwiftUI guys thought the same thing, so we just have to qualify that to say it's a SwiftUI app. Then we create our Realm app. Confusingly, in Swift, a constant is let. So anyway, so that's a Realm Swift app, and then the constructor takes the ID, which is that string we copied from the backend. Next thing I'm going to do is I'm going to create my model. So this is the class for the objects that we're actually going to store and use in our app. And we're going to call our objects chat message. Again, I need to import the Realm SDK. And we're going to create a class. It's called chat message. And chat message is going to inherit from two classes. The first one is object, which makes it something that can be stored in Realm. And the second is object key identifiable. And this means that Swift, oh, that doesn't exist. Object key identifiable, and that means that any object that's created by Realm, it's going to be uniquely identified to SwiftUI. So when the object changes, SwiftUI knows which object and which view it's got to update. We annotate the properties to say we want to persist them. So we have a persisted var. I'm going to copy that because we're going to be adding a few. So each chat message is going to have an author, which will initialize to an empty string. It's going to have the text of the message. It's going to have the name of the room. And finally, we'll include a timestamp, which will just initialize to the current time. There's one other attribute that we have to add because MongoDB demands it if you're going to store something in MongoDB, and that has to be called ID. The only thing we care about is that it's unique, and so we have an object ID, which is a bit like a UUID. And then finally, we also indicate that this is going to be the primary key in Realm. So primary key is true. Okay. So we now have our data model defined. I've just hit build. I should have done that before so we could so it would have it pre-built. So this is the first view, and this is the view that's bootstrapped with any SwiftUI app. I'm going to get rid of this preview code. Don't ever do that. I've just written a blog post on how useful it is, but it does take a bit more time when you're writing it, so I'm going to get rid of that. Okay. So I'm going to show different views depending on whether the user's logged in or not. And I'm going to know if the user is logged in by a state variable called username that I'll initialize to an empty string. And then within our view, we'll get rid of the hello world. And we'll just have if username is an empty string, then we'll have a simple text view, which says need to log in, else another text view that says okay, that's still building. Needs to be a capital for the annotations. Okay, but we actually do need to log in. So I'm going to create a new view that does the logging in for us. And so we're going to create a new file, say a SwiftUI view, because then that does the bootstrapping for us. And I'll call it login view. Again, I'm going to be bad and get rid of the preview. So instead of saying hello world, I'm going to say that I'm logging in. Then I'm going to add a lifecycle modifier to say that on appear, perform a function, and that function is going to be called login. Then we need to actually write our function. Doesn't take any arguments. And let me try and remember what we have to do here. So the first thing is that logging in is asynchronous. but the lifecycle methods, they can't be asynchronous. So we use task, and then that turns it into a synchronous function call. Also, you can get an exception. So if you're doing username password, for example, if you put the wrong password in, that would be an exception. If you're not connected to the network when you try to log in, that would be an exception. So in Swift, you use do to have a do block, and then you have a catch block, and in the catch block, we'll just say, let's print to the console, failed to log in. And this is how you do sort of put variables within your strings in Swift. So we add the error localized description, so it'll use the local language. Right, now in our do block, we're going to log in, so we're going to let user equals our Realm app dot login, and we're going to use anonymous login, which means that it'll remember which device you've logged in from, but you don't have to provide credentials like username, password, etc. And then we're going to set the, we need to pass this username back up to the parent class, or the parent view. And we're going to do that through a binding. So we've got a binding, which is a var called username, and that is a string. So now we can say username equals our Realm user, a Realm user dot ID. I didn't want to do that. The autocomplete is getting ahead of itself. So it's try, because it may have an exception, and await. So I think that should build. So now I can go back to my content view, and instead of having that placeholder view, I can just say login view. It's going to tell me I need to put in a username, which is a binding to a string. So when it says a binding, I can't just put the variable name username. I have to say $username. So it's the dollar that turns it into a binding, which makes it pass by reference. And so now, if I've coded this correctly, once this is built, it will, problem here. I've got this set to actually run on my phone, so I need to change it to a simulator so you can actually see it. Is it going to rebuild everything? So what we're going to do next is we're going to write the view that replaces the other placeholder here. Okay, so it's just launching now. You'll see that hopefully it'll say logging in, yep. And then hopefully it's now logged in. So this has now gone, because the username has been updated by the login view to something other than the empty string, we now get the text logged in. Right, so let's create the, so it's again, it's a SwiftUI view. We'll call it chatrooms view. Actually, before we look at that, there's one thing I forgot to do in here, is in almost every app that you build, you'll want to have your views embedded in something called a navigation view. The navigation view lets you do things like add the back button and the log out buttons and stuff in the top area of the screen, and it also lets you do the navigation links jumping from one view to another. So just embed everything in a navigation view. And you only do it once at the top level, and then it's used by everything that's sitting below it. So go back to chatrooms view. Okay, so I want to be passed in that username that's just been created. So let username, and it's going to be a string. So now, before I forget, I'm going to go back to Content View, and I'm going to get rid of this and make it chat rooms view. Again, I'm going to be prompted for the username. This time, I don't need the dollar because it's just doing pass by value. Okay, so we've now actually finished our top-level view. So going back here, I also need, normally you'd get these from the database, but I'm going to, for the list of chat rooms, I'm just going to make it an array of strings. So we could have Java, Kotlin, my favorite Swift, and JavaScript. Okay, we're going to use a special view called list. And I'll show you what a list is in a second, but you basically have a list of things. And we're going to iterate over all of those possible chat rooms. So for each rooms, we have to tell it how to uniquely identify each of the items in the list. And because they're strings, I'm just going to say it's actually the entire string, so .self. And then that's going to pass into our closure a room. So room will be the particular string for this iteration through the loop. And if we wanted to, we could just do text room. I'm going to add a title to this page. So let's call it navigation bar title. And we'll just call it chat rooms. And we'll set the display mode. So this puts it right into the top and makes it fairly discrete. So now if we rerun our app, so I'm doing Command R to rerun the app. Oh, have I got? I forgot to say room in. So that'll come in a second. Oh, no, it's almost there. Okay, so this is what a list looks like. So it's now actually starting to look like an app. We've got our title at the top, we've already logged in, and we've got the different chat rooms. When you click on a chat room, I actually want that to take you to another view. So for that we need a navigation link, which I mentioned in the slides. You say the destination, and for now I'm just going to make it a simple text view that says empty room. And it's a typical thing with Swift. If the last parameter is a function that you're passing in, you actually provide it as a closure afterwards. So if this builds, my Mac's running a bit slow, apologies. These have now become links, and so we can click on any of these, and we're taken to our chat room. Okay, we've got one final view to create, which is actually the view that's going to show the chat messages. So let's call this chats view. And in chats view, we want to be passed in both the username and the password. So now I'm going to go back up to our chat rooms view, and instead of jumping to that empty room text view, we're instead going to jump to our chats view. Once more, it's going to tell us what parameters we need. So username and password, again, they're read-only, so we don't need to worry about turning them into bindings. And then we're going to do a bit that's going to appear a little bit cryptic. Or what does it look like? Oh, what password? What am I doing? Why does it say? Oh, yeah. That should have been room. That should be room. Okay. And similarly, why did I put password? Room. Let's get rid of that. Okay. And now this is the bit that's going to seem a bit cryptic. That chat view is actually going to open a synced realm for our partition. And so I need to pass in through something called the environment what partition is going to be used. And so we're going to do that by setting an environment variable. So environment, and then it's basically just key and value. And so the key is /dot realm configuration, and the value we're going to give is, let's get rid of that. The value is our Realm app dot current user. So this is the logged in user. It's optional, so I have to escape it. Dot configuration, and then finally we give the room, which is the value of our partition. So this takes a bit of getting used to, but this is sort of the one bit of magic you need to do to be able to get that configuration into the view. So go back to our chats view. So now we're going to query the database. So we'll have to import Realm Swift again. And what we do is we create a variable which is actually an observed results. So this is a result set from the Realm database that's automatically going to be updated as the database changes underneath. And as we change our variable, the underlying database will get updated automatically. So observed results, we're interested in objects of type chat message. So chat message.self, it's a variable, and we're going to call it messages. I want these messages to be sorted by time, because I want the most recent messages at the bottom. So we just add something called a sort descriptor. And there's a sort descriptor initializer, and we're going to provide the key path, which is going to be the timestamp field. Okay. Hopefully that builds. Okay. So now in our room, in our body, we can just, well, let's have a VStack, because we're going to have our list of messages and then the box underneath to send new messages. So we're going to have a vertical stack. Let's label it. So I have a title. So navigation bar title. And we'll just call it, so the name of the room that was passed in. So room, messages. Okay, so now in our VStack, the first thing we're going to do is let's have a for each. So we're going to iterate over all of the messages. I don't have to tell it how to distinguish between messages because we inherited from object key identifiable. So that means that for each automatically knows how it can tell one object from another. So within our loop, we're going to have the individual message. And then to keep this really simple, we can just say text message dot text. Let's run our app. And hopefully, we go into the Swift room, and there's our I'm lonely message. So that's working. If you remember on the original, it moves to the left or right, depending on whether it's a message I sent or someone else sent. So that's easy to implement. I'm going to embed that text within a H stack. And so remember, this displays things in a row. So we're going to have, if the message is author, is the same as the username, then we're going to put a spacer. So that's going to take up all the space on the left-hand side and push our message over to the right. And conversely, if it's not from me, I want the spacer afterwards, so it pushes the other person's message all the way over to the left. And finally, I'm just going to put a bit of space around each of the messages so they're not right on top of each other. So we put padding, and then we've got to make it a small padding. Sort of, don't worry too much about that. The other thing I'm going to do is, we could have a lot of messages for more than a screenful. So I'm going to make this list actually be a scroll view. So that way you can use your thumb to scroll up and down through those messages. So this is all we have to do to make it a scroll view. Then the input box at the bottom, to push that down to the bottom, I'm going to add another spacer in my VStack. And then our box at the bottom, it's going to have two elements. It's got the box where you type the message, and then it's got the button that you hit to actually send the message. So that's going to be a horizontal stack. To input the message, there's a special field, a special view called text field. We just give it a label, so message will do. And then we have to provide it a binding. And it will update that binding to actually contain the characters that have been typed. So I haven't created that yet, so let's say we're going to call it new message. So we have a dollar because it's a binding, because it's passed by reference. And we'll just have to create a new state variable, state var, and we'll initialize it to the new message. I'm going to put a bit of space around that, so let's give it a padding of 8. Any preferred color for the background? No, I'm not going to force you. Let's have green. I work for MongoDB. Green makes sense. And then finally, for that rounded corners, you have a clip shape. And each time I add one of these modifiers, it's actually creating a new view. So that's why I say, so text field was one view, padding then makes it another, background converts it to another, clip shape converts it to another, and capsule is the shape that we're going to clip it to. Okay, so we've got our text field, but then we want our send button. So that's a view called button. Yeah, and our action is going to be to call a function called send. And what we want to display for the button is it's going to be an image, and we're going to use one of the built-in system images, which is paperplane filled. So paperplane.fill. And then the final thing we need to do is we have to actually define that send function. So it's private because it's only used within this struct. Private func send. It's going to create a new chat message. So let chat equal chat message. So call the constructor. Does that get rid of the build warning? Yes. Okay. And then we'll set chat dot room is room. Author is username. And text is our new message. So we've created it, and the magic now is that to actually persist it in the database, all we have to do is, remember, we've got that live query, which is in the variable messages. All we have to do is take a binding to messages and append our new chat message. So now it's persisted in the database, now it's going to be synchronized. And then finally, let's just set new message back to the empty string so we can type in a new message. And, one other thing I wanted to do is, let's just add a padding to the view overall. Let's rebuild that. Apologies, I'm not sure we're going to have time for Q&A, but so I'm lonely. Let's get our other window up so I can see both of them at the same time. I'm here. Oh, no. Haven't got my padding quite right there. I'm here now. Cool. And so we've got a fully functioning app. I'm running out of time. Otherwise, I'd actually show you in the cloud database. You've got those messages in there. And if I add a new document in the cloud database, it appears here. If I change the room number for one of those documents, it will actually disappear from the Swift room and magically appear in, say, the Kotlin room. So I'm going to dip back to the slides very quickly. And just to remind ourselves what we've done. So it probably felt like there was quite a lot of code in there, but there was actually less than 100 lines of code in there. About 20% of that was defining our model and actually doing the logging into the Realm backend, and the rest of it was our views. What we didn't have to write, local persisting of data, so I can restart one of those simulators, and the chat messages are still there. They're persisted locally. You could I've received messages that were sent when I was offline. I can send messages when I'm offline. We created our backend, so there's no app server needed for this. All we did was configure our cloud database and our Realm sync service. Bidirectional synchronization. I haven't got it on this list, but there's also conflict resolution. So if two apps were updating the same object, it's handled. We have the partitioning, and these documents are also being stored as MongoDB documents. And then, as I said at the start, there's no event handling in there looking for changes to the database. The database changes, the UI reflects that, which I find is really, really cool. So I'm going to skip over all of the marketing type stuff, because you don't care. And just to remind you that with this QR code, it takes you to the repo, and there's a whole load of links in there. And one of the links it's to our conference next week. So MongoDB.local London, it's on Tuesday of next week. It's in Battersea Park. And there's a 75% discount, which brings the huge price of £50 down to £12.50. So I'm going to be running a similar session to this, but it's twice as long. And so I'm going to go into some more detail, add username, password, authentication, etc. So if you fancy seeing a slightly longer version of this, like I say, use that discount code. But for now, all you need is to take a snapshot of that QR code, and everything's in the repo. OK. So thanks, everyone. I think my time's up. So thanks very much.